My name is Gary Sieling. I'm a software developer in the Philadelphia area. I work for a company called Wingspan, which is part of Quintiles IMS. And today I'm going to talk to you about building a discovery engine in Solr. And so this is specifically about full text search and exploration using machine learning. So this is practical examples. This talk is based on a case study of a project I've been working on for about 2 years called findlectures.com. And so I'm going to focus on natural language processing issues involved with building this search engine. So if you guys have any questions, feel free to post them in the chat, and then at the end, I will answer them. So the goal of this talk is to give you some practical examples of machine learning tools, specifically Word2Vec. I found that this is a useful tool to use in the context of a search engine, so I'm going to show some examples of how you might integrate this into something that you might be building, and then I want to talk a little bit about how to support users who want to explore, do data exploration. So I'm going to start by doing a quick demo of the site that I'm working on, so you can kind of get an idea of what this talk is about and what kinds of problems I'm trying to solve. And then I'm going to talk about 2 areas within the site which are doing suggested searches, and then I'm going to talk about concept-oriented search. So I'll bring up the demo. All right, so this is the site. There's about 175,000 audio and video presentations here. These are standalone talks. So there's 2 specific use cases I envision for people who are using the site. One is you're looking for something maybe to watch on your lunch break. So that means you want something just that's interesting. You don't want to spend a lot of time poking around looking for things. Just find something that's an interesting topic, or you want to do some form of historical research. And so to demonstrate one of those use cases, so you can kind of compare how this works compared to something like YouTube. For historic research, we can, for instance, type in a famous phrase from a political speech, and we'll see what happens. So here we see come back, one of the talks is this speech from a political convention, and it highlights for us the phrase that we searched for. We see it shows the time that this played, and then if we click this video, it'll start the video right at that time.
And they'll push again, and I'll say to them, read my lips.
Yeah, so you can see that's those are kind of the 2 use cases here that I'm going for. So let me bring these back up. So as I said, this came about as part of a company lunch and learn. So we took talks that we had found curated manually, collections of things that were interesting. So this could be anything from a tech conference like this one to interviews on TV or university lectures, political speeches, anything that might just be interesting as a source of content. And this site, one of the goals here is to provide a little bit more metadata than YouTube has so that people could just poke around manually. This is obviously not so much the machine learning at this point, but this is something to provide a basis for future projects that might come out of this. So here you can see you can search by when a talk was given. That just on its own, those 2 attributes are pretty useful. The data comes from sites that are just scraped custom. Here is an example of a museum website which is dedicated to a famous journalist named Mike Wallace, who did a lot of TV interviews in the 50s and 60s. And here you can see on this site, it has the names of the people, when the talk was given, the transcripts, videos, descriptions of these things, little bits about these people. So this information is what's being scraped and put into the site. And there's information that also comes from YouTube. So what can happen here is I potentially am pulling data from multiple sites. So for instance, on the left-hand side of this, there's some process that runs that crawls the site, pulls in as much metadata as available. And then if there are links to YouTube, I also pull that organization's YouTube channel and then combine them together based on the title or the YouTube identifiers. And then after these 2 things are merged, there's some separate scripts that run after the fact that update this information. So the two important things here, though, are there's two collections of text which you can use for natural language processing experimentation. And those are transcripts, which YouTube provides. These are generated automatically by a machine learning tool that they use. I've also run some of the audio from video and audio files through some different APIs to test them out. So there's a mixture of sources here from where this comes from. And what I've also done is to pull in about 10,000 articles from that have been posted or Reddit, so that I have an additional data set. And I'll show later how that's actually kind of fits into this. But both of these are useful for text processing. So I want to support users who want to do exploration of this data set, like I said. So these are 3 attributes you're looking for. In doing that, you want something of good quality. So the non-machine learning way to approach this, which has worked out pretty well up till now, is to say, take a list of publishers who are really good, run some scripts to find things which are problems like audio issues or something that's really heavy or something that's too short, too long, that kind of thing. Remove those from the collection or derank them, and then apply a little bit of randomization. And so the randomization gives you effectively the same kinds of results every time you go to the site, but every day it's a little different. So that gives you a feel that's a little bit more like Reddit. It's just not as obvious that you're getting different things each time you come to the site. So one of the features that a lot of search engines have to support data exploration is this concept of suggestions. And this will take 2 forms typically. One is type ahead as you're typing in search queries, or a list of recommended searches, which will typically show up down at the bottom of a page. And there's a few different ways you can approach this, and this is where we start to get into real interesting machine learning problems. So if we look at how Amazon does this, I think everybody probably knows at this point, use people's purchase history to make suggestions. So here I've taken a screenshot of a page from an author who wrote a famous biography of Alexander Hamilton. This incidentally was used as the basis for the musical that's become fairly famous. So this author, if you look at the related authors here, these are other people who write biographies, but the way that Amazon figures this out is by looking at people's purchase history and saying, the people who bought this guy's books also bought these other people's books. If you look instead at Google, they do clickstream analysis. So if you type in Ron Chernow and then you type in Ron Chernow website, eventually they'll figure out the pattern and use that as a search suggestion. The challenge to both of these 2 approaches is if you're working on a site like, for instance, my site, which is a hobby project, so there's a relatively much smaller user base, or if you have users who don't have knowledge that you can extract, or you want to maintain your users' privacy and not track things that they're doing, these 2 approaches don't really work very well. So a third option might be to look at some big data set like Wikipedia and see if we can incorporate that into the site. And here you can see that they have a lot of information about this author. They have a list of his books. So clearly there's something here that might be interesting. The one problem with Wikipedia is you'll also see some noise information. Like, for instance, in this guy's case, they have a list of all of his honorary degrees, which I think is probably not a useful piece of information for generating suggestions. And so this is where Word2Vec becomes an interesting tool that we can use to apply to search engine problems. So for people who aren't familiar with Word2Vec, it's a family of techniques. There's a lot of different tuning options for this. But what you do in essence is to give it a body of text, and it learns something about the meanings of words by looking at the context in which the words are used. So it counts words around each word, runs the values through a neural network, and then the output of this as a vector, which you can do some data manipulation on. So the famous example that's in all the papers that everyone uses in talks is it learns this concept of gender by seeing that man is to woman as king is to queen, because these are mathematical vectors, you can do addition and subtraction. So you could say king minus man plus woman is queen. Because Wikipedia is a big data set, I found that some people have been maintaining pre-built models from Wikipedia data. And one of the nice things that they've done with this model is wherever there's a link in the Wikipedia article, they include the identifiers of the article so that you can get phrases in the model, because typically this type of model is built around individual words, which isn't always what you want. As you can see in my example of an author, that's a 2-word phrase. So the data format looks a little bit like this. This is from, this is truncated a little bit, but this is the output of the Java implementation of Word2Vec. This is for one word, we have the frequency it occurs, and then we have an input vector and an output vector. These are, I think I trained this particular one as a 50 items in each vector. But this is just to give you an idea of what this looks like. And then these are things that we can work with. The way similarity is measured in Word2Vec, if anyone's not familiar with this, is based on the cosine of the angles between these vectors, not, for instance, the distance between the ends. So this gives you, you're typically looking at like numbers from 0 to 1, which is very different than something like a full text search engine, which could be numbers from 0 to infinity. I did some experimentation on the data set that was provided here to see if this addition and subtraction worked out well. This is an example that I found that seems to work. So if I look for the vector for Gloria Steinem, who's a contemporary feminist, and subtract the word person and add the word ideology, we get a bunch of words. These are the 4 closest Wikipedia article entries to the output of that vector. This isn't necessarily defining meaning, it's just these things are related in some fashion that it has discovered. So these, I think, are probably pretty appropriate results. They're at least all related to feminism. But one of the things that this makes really clear, I think, is that when you train this model, you really need to think about entity recognition, which is a whole older class of problems. So any phrases that we might be interested in identifying separately, you need to run some pre-processing step to make sure that they get combined. So for instance, if I was interested in having machine learning as a phrase be something I want users to search on, I probably am better off replacing all the entries with machine_learning. That will reduce the ambiguity for the component terms. And it's also worth thinking about grouping synonyms. One of the things that you notice if you just train this model on a body of text is it typically recognizes a word and its plural as the 2 closest, as being very close to each other. And for a lot of things, that's probably not useful. So the steps that you're taking at this point are a lot like preparing something like Solr or Elasticsearch for use. It's not exactly the same, but there's a lot of overlap. So I think if you were training Word2Vec, it's worth researching how those tools are used, because you might, for instance, do other things like remove accent marks, or for some use cases, you might want to think about removing stemming. So now, having obtained this data from Wikipedia, you can take and look up the entries in DBpedia, which is just a JSON form, sort of a Wikipedia that has a lot of metadata. This is kind of an example of the kinds of information it has. You can find out specifically if an entity is a person, place, or thing. You can find out the display name for it. There's a lot of trivia that goes along with it too. So you can find out things like whether a person is left or right-handed or something. So there's all kinds of stuff you can do with this once you have it. So if we search the model that we've obtained for Martin Luther King Jr., I want to show here what, just to kind of prove out that this works well for suggestions. So if we search for this guy, for his name, we get, I think 6 of these results are relatively appropriate. Martin Luther's probably not the right term. So you can see that it makes some mistakes. But whether, what means mistake here is, of course, very subjective. But these are basically the closest Wikipedia articles to Martin Luther King Jr. The way that this is working is it says these words are used in the same context that his name is used, which is appropriate. If we instead search for a topic instead of a person, just to prove out that this isn't just this one case, like Vietnam War, we get some interesting entries. One of the things I think is interesting here is that for the third result, this is a really long result that we wouldn't necessarily be expecting in a search suggestion, but it's interesting that you can get something of this length. But I think that these are appropriate results. There may be something that's better, but these are definitely appropriate for a search engine like this. So when we apply this to Ron Chernow, what we get is a list of people who are professors, historians, biographers. Generally, if you look these, a lot of them are interested in Revolutionary War history. So before I go on to the next example, I want to useful about this in a search engine. One is that you can do some form of, it's not just synonyms. So sometimes you'll see more general or more specific versions of words also show up in this data set, which is a useful property. Some people use Word2Vec as a way to improve the recall of their search engine. So if you have, say, if you search for a job title in your search engine and you run out of jobs to give someone, you might start searching for related terms so that you can get more than 10 results. And this is also a great way to incorporate a secondary data set into your system. So if you're working on a site where your users are uninterested in helping you get data that you need to run the site, like enterprise search is a good example of this, or if you have users who are antagonistic towards what you're doing, this potentially could be an interesting way to incorporate data from outside into what you're doing. And it's also a good way to think about privacy because you can do tuning of a search engine without having to track people particularly. So the next stage of this then is to talk about concept search, which I think is an interesting area of, it's an obvious next step for thinking about what you can do in the Word2Vec. So let's take an example of how someone might use my search engine. I've had a specific request from someone where they were searching for talks on writing, and they want things about creative writing or how to be a better writer, how to publish books, how to self-publish books, that kind of thing. And so they searched for writing but not code. And of course, in a traditional full text search engine, this doesn't work very well because it's just looking for those specific words. So it will remove talks with the term code in them, but that's not really what the person's trying to express. They're trying to they want to exclude writing CSS, PHP, JavaScript, etc. But they do want things like poetry, fiction, copy editing, copywriting. So even if these words don't appear in the title or the body of the talk, we expect that they'll come back. Another example of this that shows a little bit broader use cases, let's say you were searching for recipes and vegetarian food, but not dairy. You might expect an output of this to be vegan cooking, for instance, which is one possible solution to this problem, but it just implies on the negative side of this a whole hierarchy of objects. So you're removing milk and cheese and every brand of those things. So from what I've seen in research at this point, this isn't necessarily purely solvable in the general case where you can't just find someone who find a machine learning model that will construct that hierarchy of objects. But what you can do is approximate it using Word2Vec. And then there's some interesting problems around this once you start actually trying to do it. So the next set of slides will be some demos of some specific experiments I've done using some models that I trained. The way that I'm using this is to generate email alerts. So if you were to go to the site and say, I want talks on Python and machine learning, what you probably expect are talks about scikit-learn, TensorFlow, etc. If you instead typed in Scala and machine learning, you might expect deep learning for J or Spark or something like that to come back. And so using this, you can kind of get tune the results a little bit for people's interests. And the value of doing this in an email construction is that the construction of the email can take longer than a traditional search engine might take. So if it took, say, 30 seconds to generate an email, that's not a big deal. Whereas in a search engine, that is a big deal. This is what the collection looks like when you get the email. So you get both articles, which are just coming from Reddit, and then videos. And they're both produced essentially in the same way, but I'll show some specifics here. So there's a non-machine learning approach to tuning search, which is very effective and very fast, called the Orochi Algorithm. This was invented in the early 70s. And it's worth noting that since I mentioned job search, I actually saw a talk by someone at DICE who did an excellent overview of this at a solar conference. So what this algorithm does is you run a search, you get common terms that come back in the search, and then you use that to ask yourself the question, what should I have searched for if only I'd known about this space of problems? So in the Python and machine learning example, you would expect for the Orochi algorithm to find terms like TensorFlow and scikit-learn and then search for those instead. This is very fast. It's a really good way to improve the relevancy of search engine output. And I've included a link here to the DICE GitHub page where they have written a Solar plugin, which works very well. It's very easy to set up too. So what this gives you for talks or actually articles, from the collection from Reddit is, in our Python plus machine learning example, is this list here. So you get things like I mentioned, scikit-learn and Python, Pandas and Python, image recognition, some classes, specific algorithms. So these, I think, are like pretty good results for this particular search. The difference between using Word2Vec and the Orochi algorithm, aside from performance, is that Word2Vec has a concept of distance between terms, which we can use, whereas the Orochi algorithm is just using tokens that it finds in the index. There's a lot more tuning parameters when you build Word2Vec. So I think in the future, it probably has a lot of potential for solving different niche specific problems. And I also found that if you run the Orochi algorithm on something where you don't have a lot of content about the topic you're looking for, it doesn't do very well. So it becomes valuable to then tune something on a bigger data set. So for instance, this is why I think it's valuable to have the set of text from both Reddit and some YouTube videos, because you could potentially train two different models on these pieces of text, but apply one to the other. And that I think will be potentially valuable. But they're both similar in that they both take into consideration something about the context in which words are used. Although for the Orochi algorithm, it's just document level context, whereas Word2Vec, it's much more localized. So the reason that you might want to think about separating out YouTube auto transcripts and Reddit articles is that YouTube makes a ton of mistakes, and any API that does automatic transcriptions will make a lot of mistakes on the data that they generate, at least for now. And so when I trained Word2Vec on this data set, including a bunch of technical talks, if you search for the word code, the closest word to code was actually coat, which I think is interesting because if you were a machine, those actually probably sound pretty similar. I think there's probably some potential for someone to use this to improve the quality of transcriptions if you knew something about the data set that you were doing the transcriptions on. So if we expand this concept of synonyms and we say, let's take a query like Python machine and learning, and let's find the 25 nearest terms for each of these. This is a piece of Scala code that would pull these from this model. It doesn't matter if you don't understand this, I'll show some more examples of what this looks like. But what we're going to do is just take these, use the weights or use the distance of each of these terms from the source term and use that weight to boost things that are a lot closer. Things that are further from Python machine learning will not boost by as much. So to take the previous example of a graphic here, what we're doing is computing the distance between each query term and each of the top n closest terms, and using that to construct a search. This is how one of these searches would look if you were running against Solar. So what we're doing here is saying, I've simplified this obviously to fit a slide, but we take terms which are related to Python, we boost them by the distance. So that's things like software, database, browser, Excel. Some of these I think are intuitively more related, and some of them are a lot less related. What's important to remember here is that when you run this against a full text search engine, these boosts are not pure values. They're going to be filtered by how frequent a term occurs. So when you run a search like this against something like Solr or Elasticsearch, it's going to add weights to all of these terms based on how frequently they occur in the data set that the search engine actually has. So if you find that a term is very close to Python, is also a very common term, like software might be a really common term, the boost that it gets here is not going to end up weighting for very much at all. So this does actually end up working because of that. So these are results that you get from this. This is very different than the Orochi algorithm results, but I think that they're still appropriate. I've highlighted a couple things here where you see the scikit-learn example coming back, and you see a Spark example. I think the Spark example is interesting because even though it says it's a Scala talk, a lot of people do use Python with Spark, so I think there may still be something appropriate here. And we'll get into some ways to improve this some more later. But you can see that these all do seem to be roughly appropriate. I think if these were topics you were interested in, these are probably all things that you would find interesting. If we then do that for writing instead, everything that comes back appears to be appropriate to the use case that I was describing before, except for this one in the middle, which is a tricky example because it's rewriting, rereading, rethinking web design. So we have something that's kind of code related and something that's really not in the title. And that's a little bit difficult at this particular moment for this technique, but we'll be able to improve that further on. And the way that we would improve this is we want to think about how do we tell whether a document is about the term that we search for. One of the problems that you see a lot in doing full text search is it's really easy to get a result where the term that you searched for occurs once in a document, but it might be in a footnote or used in a different way than you meant it. So how do we tell if the document is actually about the query we search for? And there's a way that you can approach this, which is to find the mean of all the term vectors in the document, find the same thing for the query or individual terms in the query, and then compute a distance between these. So if you do this without having pre-computed all of these vectors, this can take a little bit of time. When I ran this a few days ago to generate these slides, it took just about 6 minutes on one of my examples, and this is just to compute. Basically, all the time goes into computing the vectors for these documents. And this is just 100. So what we're doing is taking 100 documents from our previous search and then trying to resource them to improve the output. To show this slide again, what we're doing is computing the distance between the average of all of the terms in the query and the average of all of the terms in the document. This doesn't necessarily sound like something that would work, but it is something that you'll see show up in some papers as a proposal for how to do this, and it does seem to work well, at least for re-ranking the top sections of documents, which are already pretty close. It works really well. This doesn't work very well across an entire data set, from what at least some of the research I was reading says. So when we run this then on that writing example, we get results which are pretty much completely different than we saw before, but they're all seem to be completely relevant. So we see things about teaching creative writing, things about writing autobiographies, creativity, some articles about well-known literary figures. So I think this at least demonstrates that this technique can work. I don't know necessarily how reliable this works in every case, but for the cases that I've tested this on, that people have given me, this seems to work pretty well. So there's a different problem that we might want to think about. People put in multiple terms sometimes when they're requesting these email alerts, but what I've noticed is that some people will request terms that are related to each other, where the terms are modifiers, so Python and machine learning or Python and programming. Some people put in just all of their interests, which are completely unrelated terms. So art and hiking, for instance, is a real use case that someone put in. And this isn't something where we expect intersections of these two to come up potentially ever. So I think it would be valuable to think about a way to combine the terms that are actually combinable and separate the ones that are separate. And the way we do that, instead of computing distance related to documents, is we're just comparing the individual terms in the search results. So we're getting the word vector from word to vec for each of these terms and seeing how close it is to the others. And so this is a piece of Scala code that obtains that information. So this visually is what we're trying to do. We're taking one term and another term and we're comparing them to each other and getting the distance. So in the specific model which I trained for Python and programming, we get 0.61 for the distance and 0.1 for hiking and art here. So those you can end up separating. So in this example, we might say something like, effectively, we're generating Python and programming for a query, or hiking or art. I think originally I had violin in here too. So this is building on the techniques used before. We're still using the aboutness concept or something to get the actual terms that we would substitute in for Python programming. But this gives us a way to handle two different use cases here. So the final example I want to talk about is thinking about how we handle topic diversity. One of the issues that I haven't mentioned so far is that you can get, for a given term, a lot of related articles or talks or something on the same subject when you put something in. And this, for a system where you're building email alerts, is potentially really irritating to the end user. So the first example is kind of cute. I think it's not necessarily a huge problem, but when you search for writing, someone got an email where they got 2 Star Trek related talks in one email. And then in the Python example, I actually got one email where there were 3 articles which were on the same, essentially the same subject, which is this thought that this library called Pandas is responsible for the growth of Python as a programming language. So realistically, I don't think this is something I want to see in search results. If you set up alerts on Google for company alerts or something, you'll get this a lot. And I think if you're trying to learn, this is not necessarily helpful. You want like breadth of content rather than a lot of really specific articles, basically rewritten versions of each other. So this isn't something which is well handled by many full text search engines. Full text search is typically oriented around finding documents that are as close to the search you looked at as possible, which naturally lends itself to this kind of clustering. So there's 2 approaches I'm going to show to dealing with this. One is a simple and fast approach, which is to use a Kmeans feature of Solr. Solr has the ability to find common phrases in documents. So here I've searched for Python in the transcripts of these talks. And these are phrases that Solr thinks are common phrases in talks. There's under each of these, it has in the output of the search engine, it has a bunch of examples of documents that fit each of these. So dealing with Unicode, not really sure what false, really, or equal to true is here, but debugging is something. Fortran is related because there's a lot of the mathematical work that people do can be done in Fortran. We see there's things here about working with Android and also the Pandas thing again. So what we could do to generate more diversity in the output is to take one of the talks from each of these categories and display the result. And I think this works pretty well. I've highlighted a couple here where you can tell just from the titles that they're very different. One is about web development. One is about Python, C++, C, and Fortran. One is about software engineering culture at Facebook, and one is about Python for Ruby programmers. So probably these are all a good bit different. It's a lot better than the previous example where you got 3 articles on the same subject. The downside to this approach is I haven't seen a good way to combine this with the other problems I was trying to solve, where I talked about how close a document is to the query. This basically circumvents all of the work we were doing before. This probably could be combined, but I haven't found a way yet. So if we instead thought about a way we could do this with Word2Vec, what we could do is we could say, let's take two documents in the output and say, how close are they to each other? So again, we're taking all of the words in the document, computing the average of those words, and then computing a distance. So what we do is we take the top document that comes back, we find, say, the top 50 or 100, we find the least related document, we average those two together, and then we do it again until we get all these results. So the answer we get here, I thought that this would be really hard to test and to tell if it was really working. So what I've done is to specifically search for Python and Pandas. So we get the original article back that I showed, and then we get a whole bunch of completely different things. So something about the future of Python, something about geographic search in Python, something about databases in Python, something about building a Twitter bot, and so on. So this, I think, is a pretty good answer. It's worth noting here that this one took about 1.5 minutes to re-rank these results. So to summarize, the way I'm doing this and what I've seen supported in some papers I looked at was you take a search engine that you have working, you take top n results, you reshuffle them to solve your problem, and then you iterate again. So you might take a few less results from that, reshuffle to solve the next problem, and so on. The value that this gives you is tremendous, but it does require a lot more computing power than a traditional search engine. I think there's probably a lot of room to improve this in terms of how they're constructed. And I know there's some effort on at least in the Lucene community around incorporating some of this information into the search engine, but for search engines, but for the time being, there's still some challenges, I think, here, unless you're doing something like my email example. So if this topic interests you, there's a couple books I found really helpful. This one called Relevant Search, which talks a lot about search relevance issues and ranking. Deep Learning and Practitioners Approach is, I think, written by someone who's writing Deep Learning for J, which is a deep learning library for Java. If you do research on this, you'll also see a lot of people using GenSim, which is the Python equivalent. And then there's a tool called Annoy, which is it's an interesting, really fast clustering tool that Spotify is using for their data set. I think it has a lot of potential if you poke around with it. I haven't been able to integrate it into my system in a way that's useful. And then there's some GitHub links here to things which I found useful, and also my GitHub. If you're interested in just getting some talk suggestions, I've taken and set up an email list that sends out all of the favorites that we used for Lunch and Learns. And then you can also find on the site the page that I showed earlier. It's really hard to test a lot of these things. So if you're interested in these topics, I posted links to a couple papers here that I found helpful. The first one is not about NLP, but it's about extracting slides from videos, which is a challenging but interesting problem. And then the second two are about the application of Word2Vec to search style problems. One of these is written by a Bing research team, which has a lot of good material. And they've done much more sophisticated testing of what they've done than I have. So if you're interested, you want to talk more, feel free to contact me online, different ways. If anybody has any questions, you can feel free to post things in the chat, and I'll try to answer them. So the first question is there any specific way you arrange the documents in Solr to help with this? I have separated out the transcripts that I know are written by a human from the transcripts that are written by a machine. I think it's probably important to separate those out because you get different categories of mistakes between the two of those. And then there's a lot of metadata. I'm using Solr specifically because aside from using it to build a site, it's also just a good way to get results really fast. It's a nice tool in the sense that you don't have to spend a lot of time tuning query timings. And the second question, do you think it would be possible and worthwhile to build an organic tree with persistent topics and their dependencies for learning and discovery and indexing? There are some people who are researching this. This is a huge, from a manual perspective, it's a huge amount of effort to do that. I think one of the potential values I see out of this is I think you could do something like take an article and say, give me talks that are related to this article. And I think you might be able to say, are there novel concepts in a talk, one talk relative to another, like if you divided it up into sections or something. And that's something I've been thinking about doing, but I haven't pursued yet to prove out if it actually works. The use case I see there is if I were to go watch computer science talks, for instance, having a degree in that subject, it's hard for me to find stuff that's unique to my experience. But if I said, here's a bunch of things I've watched, give me the stuff that's new, I think the concept tree thing would be potentially valuable. But I haven't found a way to do that yet. But I was kind of building up to maybe doing some experiments in that case. I don't have anything to share yet, though. So the next question is there a good approach to break the document down into multiple vectors representing separate ideas or topics, as opposed to mixing the whole thing? So I think this is a good question. One of the reasons why I've pursued crawling articles from Reddit is that they're just naturally categorized, and it tends to give you a lot of stuff that's really focused on specific things. So the problem you're describing is a interesting problem, and there's some research on this. Generally, the people who I've seen who are concerned about this will just break things down by paragraph. And there's some mathematical exercise around that I don't completely understand. But if you were going to have to do that, I think you'd have to do like paragraph by paragraph or chapter by chapter if it was a book. But my hope is that by using Reddit, I'm just naturally using things which are focused, and that you could apply that to a bigger data set. Thanks, everyone. Feel free to contact me afterwards if you do think of anything else you want to talk about.